Hi all, welcome to Engineers Think Box. This is Sharu. So in this video we'll discuss the steps involved in designing an analog Chebyshev filter. So similar to the analog Butterworth filter, this analog Chebyshev filter also involves 5 steps in order to design it. So the steps are somewhat similar. So let's get into it. Actually, when we are going to deal with the Butterworth filter, we will be dealing with two specifications. That is, first specification will consist of alpha S, alpha P, and omega S and omega P. I'll give the videos in the description box so that you can check it out. And also, and the second specification will consist of lambda, epsilon, omega S, and omega P. So coming to the Chebyshev filter, here also there are two specifications. From the question, either you will be able to take this specification or this specifications. So based on the specifications which we are going to take, we will be applying the formulas. So the first step in the designing of analog Chebyshev filter is we will be finding the order of the filter n using the formula. This when we are having the specifications alpha S, alpha P, omega S and omega P, and we will be using this formula while we are going to have the specifications lambda, epsilon, omega S and omega P. So this is cos h inverse square root of 10 power 0.1 alpha S minus 1 divided by 10 power 0.1 alpha P minus 1 divided by cos h inverse of omega S by omega P. Either this formula or this formula, that is cos h inverse of lambda by epsilon cos h divided by cos h inverse of omega S by omega P. So coming to the next step, we will be rounding off the n value which we have received in the previous step to the next highest integer. That is, if we have got n value is greater than or equal to 1.8 na, we will be rounding it as n is equal to 2. If it is 3.8 na, n value will be equal to 4. Next highest integer we will be rounding off the values. So before that, how we are going to take this cos h inverse in the calculator is, you will be pressing shift and there is a button called hype in the calculator. If you press that and if you press cos, you will be ending up with this shift plus hype plus cos. If you are going to operate these three buttons, you will be ending up with cos h inverse in the scientific calculator. So now we are going to calculate the poles. So now what is poles is, before getting into it, we know that the in the end the transfer function will consist of numerator and the denominator. Okay, when we are going to equate this numerator is equal to 0, the answers which we get are called as zeros. Okay, when we are going to equate this denominator is equal to 0, the answers which we get are called as poles. That is, here poles refers to the denominator. Here we are going to calculate the denominator, for which we will be using this formula. Okay, Sk is equal to a cos phi k plus jb sin phi k. Here each term has a separate formula for that is, we will be, see here it is phi k, right? For phi k the formula is pi by 2 plus 2k minus 1 into pi by 2n, and for this a there is a separate formula, that is omega p mu power 1 by n minus mu power minus 1 by n by 2, and for b it will be like, here it is minus, so it will become plus here. That's all. That is the only difference for a and b. And in order to calculate this mu, there is one more formula here, that is epsilon inverse plus 1 plus epsilon power minus 2. Now the thing is, as I said earlier, there will be two specifications, right? The first specification will contain alpha s, alpha p, omega s and omega p. So when these specifications are given, I need to calculate mu. But if you are going to have this specification, that is lambda, epsilon, omega s and omega p, and that time you will be calculating using epsilon value. But when these specifications are given, you will need to calculate it, for which you will be using this formula. First, initially you will be calculating epsilon value using this formula, that is square root of 10 power 0.1 alpha p minus 1, and from this epsilon you will be calculating mu value, that is mu is equal to similar formula, epsilon inverse plus square root of 1 plus epsilon power minus 2. Okay, so this is the step 3. Now in the step 3 we will be calculating the values. For each values of k we will be calculating the things s value, that is if for when k is equal to 1 we will be getting s1, when k is equal to 2 and if we are going to calculate we will be getting s2, and we will k is equal to 3 we will be calculating s3. So now we have got all these things, right? Now we will be finding the denominator of the polynomial by using this formula, that is s minus s1 into s minus s2 into s minus s3. Okay, using this formula we will be calculating the denominator of the polynomial. All these steps will be clear once you are going to solve the problem. So this is just the outline of the problem. Okay, so now we have calculated d of s, that is denominator from this entire for the entire transfer function. That is what is this thing is, we will be representing the transfer function h of s as numerator, that is n of s, by denominator, that is d of s. Now we have calculated the d of s here. Now we are going to calculate the numerator of the transfer function, for which the value will be dependent on the order of the filter n. If the n value is odd, what you will be doing is, this d of s is there, right? There is an equation for d of s is there, right? Wherever s is there in this d of s, you will merely substitute value of s as 0. And you will solve the problem, you will solve the equation. The answer, the final answer is the numerator of final answer will be the numerator when n is equal to odd. When n is equal to even, what will happen is this step will take place, that is we will be substituting the value of s is equal to 0 in the denominator of s formula, and you will be ending up with a solution like this. For n is equal to odd, you will be ending up like a solution, right? This solution will be divided by square root of 1 plus epsilon square. Okay, this is the only difference between n is equal to odd and n is equal to even. So the thing is, now we are just seeing the outline of the entire problem. Once you are going to solve the problem, the steps will be furthermore clear. So stay tuned for that video on the analog Chebyshev filter problem design. Thank you.